All right, so let's just continue right where we left off. Just do a bunch of problems, all right? So again, we got this big circle. Analyzing this big circle. Tick, tick, that means that's 3. So that's 6. All right, now we want the area of the big circle, pi r squared, pi 6 squared, or 36 pi. All right, now we want 3/4 of that. So we're gonna worry about that at the very end. All right. Then we got the area of the little circle, which again, just right here. All right. The area of this little circle has a radius of 3. So we have that. So the shaded region, we only need 3/4 of the whole thing. It's going to be 3/4 of whatever the difference is. All right. So it's going to be 3/4 of 27 pi. Which, after some calculation, just tells me that it's 81 pi over 4. All right. So again, just break it up into smaller steps. We got this circle. We got the smaller circle. Let's subtract them, and we only wanted 3/4 of that. So bada bing, bada boom. That's how we do it. All right. Now with this circle, again, let's just focus on the circle. The area of the circle. We can think of this as a radius, pi r squared, pi 16 squared, which becomes 256 pi. All right. Now, let's focus on this square. All right. There's going to be some calculations I have to do. All right. 16. All right. Now, we haven't done this in a while, but we get to use special right triangles. All right. These come back again and again. All right. So we can think of this as a 45, 45, 90. 45 degree, 45 degree. All right, where the hypotenuse is 32. All right. And remember, to get to the legs, you're just going to multiply by radical 2 over 2. All right. So then that gives me 32 radical 2 over 2, which is equal to 16 radical 2. After I simplify the 32 over 2, that becomes just 16. All right. Now, remember the area for a square is just side length squared. We found the side length to be 16 radical 2. So that's what's going to be squared, which then is 16 squared. Radical 2 squared. 16 squared is 256. Radical 2 squared is 2. 512. All right. So then the area of the shaded region is just the area of the circle minus the area of the square. So it's 256 pi minus 512. Again, that's the exact answer. All right. Plug anything to the calculator, you'll get a estimated decimal. All right, so cruising right along, we just got some more problems right here. We're going to find the measure of the central angle. So now we're reverting back to what we were doing earlier. Again, it's good to bounce back and forth between things. That way, it strengthens your skills and helps you remember what you got to remember. All right, now looking at this, 16 pi is the sector area. 24 is the radius. All right, so I'm going to call the central angle theta over 360. Sector area is 16 pi over pi 24 squared. pi in the numerator and denominator, so I can cancel those out. I'm going to be left with theta over 360 equals 16. 24 squared, 576. Divide both sides. This, again, 16 goes into 576 36 times. Again, we have to be good at using a calculator. We have to understand how it works. It's going to lead to a lot of success. Cross multiply. I'm going to get 36 theta equals 360. Divide both sides by 36. And theta equals 10. All right. Cool beans. Find the approximate length of the radius in the circle below, okay? So same exact problem as above, except it's different. All right. Central angle over 360 equals sector area over pi r squared. Central angle is 165. Then we got the 360. Sector area is 88 pi. And we have pi r squared. We're looking for r, okay? So this is approximate. So I don't have to be too obsessed with simplifying. Again, simplifying in some cases can help, like I'm going to get rid of the pi in both numerator and denominator. 165 over 360 does simplify, but I'm not going to worry about it. Since it's set approximate, I'm just going to be really good at using a calculator. 88 times 360 is 31680. Divide both sides by 165. R squared equals 192. And then take the square root of both sides. It's going to be a number slightly less than 14. 13.9. Smiley face. All right, and we'll knock out the rest of the video, or